In a previous video, we covered standard structural systems like steel, concrete, masonry, and wood construction. However, do you ever wonder how complex structural systems like space frames, arches, or inflatable structures work? These systems, while not as common as post and beam systems, are still important to understand if you're an emerging architecture professional. They are the result of a complex interplay of advanced physics, innovative materials, and cutting-edge design. They are crucial to the success of any ambitious building project. So buckle up as we delve into the first complex structural system: trusses. Trusses, the skeletal framework that holds up our roofs and bridges, but what exactly are they? Trusses are essentially triangular frameworks, used in a broad range of structures from small sheds to sprawling bridges. They're incredibly efficient in supporting weight because they channel it along the members and into the supports at either end. Now let's break down a truss into its core components. There are three key parts: the web, chords, and joints. The web is the inner framework of the truss, often a series of interconnected triangles. The chords are the outer members of the truss, typically taking on the lion's share of the tension and compression forces. And finally, the joints, the points where the web and chords intersect, holding the whole structure together. These components work together, creating a robust, weight-bearing framework that we call a truss. Now that we understand trusses, let's move on to another fascinating structural system: arches. From the Roman aqueducts to the Gateway Arch in St. Louis, arches are a testament to human ingenuity. Arches are not just a historical novelty, they're an integral part of architecture and structural engineering. With the right understanding, you can harness their power in your designs. Let's delve into the bare bones of an arch. It's a curved structure designed to span an open space while supporting weight from above. The curve of an arch, known as a funicular shape, is its secret weapon. This shape allows the weight to be carried along the curve to the supports at each end, minimizing the bending forces on the arch itself. Now, these supports react to the load in two distinct ways: vertical reactions, which counteract the downward force of the weight, and horizontal reactions, which counteract the outward push of the arch. These reactions are key to maintaining the arch's stability, but there's another force at play here: thrust. Thrust is the force that an arch exerts along its length, pushing outwards on its supports. This is why arches often have substantial supports or are part of a larger structure that can resist this outward push. Now let's touch on a special type of arch: the three-hinged arch. This arch has hinges at each end and one at the crown, which is the highest point of the arch. These hinges allow the arch to move slightly under load, reducing the stress on the structure and making it more resistant to damage from loads like snow or wind. So, why does all of this matter? Understanding these principles can help you design structures that are not only beautiful but also structurally sound. Arches can be used in bridges, buildings, and even furniture, bringing a blend of aesthetics and strength. Arches, a marvel of engineering. Next, we turn our attention to rigid frames. Rigid frames, the backbone of many modern buildings. A rigid frame, as the name suggests, is all about rigidity and interconnectedness. It's a structure where vertical and horizontal members unite to work as a single structural unit. This is a stark contrast to a post and beam system where each component largely operates independently. Think of a rigid frame like a family working together. Every member, whether vertical or horizontal, has a role to play. They all contribute to the stability and strength of the structure, just as each family member contributes to the household. Let's take an example of a gable frame one-story building. Here, the roof and the walls form a single, rigid structure. Each component supports the other, working harmoniously to withstand various forces, be it gravity, wind, or seismic activities. Rigid frames, sturdy and reliable. Now let's explore another interesting structural system: space frames. Space frames are tri-dimensional structures composed of interlinked rods or tubes, providing impressive strength and rigidity. Imagine a three-dimensional web where each part works together to share the load. One of the best illustrations of a space frame is a triangulated space frame. Picture a series of interconnected triangles, each one contributing to the overall stability. The strength of a space frame comes from its design, where each component shares in the load-bearing work, distributing weight and stress across the entire structure. The result? A lightweight yet incredibly strong and stable system. Space frames are highly adaptable, making them perfect for a variety of applications, from large-scale architecture to vehicle design. They are also remarkably efficient, minimizing material usage while maximizing structural performance. Space frames, another fascinating aspect of construction. Inflatable structures, a breath of fresh air in the world of construction. This innovative approach to design and building is as fascinating as it is functional. But what exactly is an inflatable structure? Let's dive in. An inflatable structure is, at its essence, a structure that maintains its shape thanks to the pressure of the air inside it. It's like a balloon, but on a grander and more complex scale. The air pressure inside the structure is higher than the air pressure outside, and this difference in pressure is what keeps the structure inflated and stable. Now, let's delve into a specific type of inflatable structure: the double-skin inflatable system. Picture two layers of material, like two skins, that are inflated separately. The space between these two skins is filled with air pressure, creating a stable structure. This design allows for increased stability and versatility, and it can be used for a wide range of applications, from temporary event spaces to emergency shelters and even architectural installations. The beauty of inflatable structures lies in their lightweight, transportable nature. They can be deflated and packed away when not in use, making them a fantastic solution for temporary needs. Furthermore, the ability to inflate these structures on site reduces the need for heavy machinery during installation, saving time, energy, and resources. But don't be fooled by their seemingly simple concept. Designing and constructing inflatable structures requires a deep understanding of material properties, air pressure dynamics, and structural stability. It's a fascinating field that combines architecture, engineering, and physics to create functional, visually striking structures. Inflatable structures, then, are more than just large balloons. They represent a unique blend of science and design, a testament to human creativity and ingenuity. They challenge our perception of what a structure can be and open up new possibilities for architects and designers worldwide. Inflatable structures, a testament to human creativity. As we conclude, let's take a moment to review what we've learned. From trusses to inflatable structures, we've covered a wide range of structural systems. Let's take a quick trip down memory lane and run through the key points we've discussed. We kicked off our journey with trusses, the triangular web of beams that provide support for roofs and bridges. They're an efficient way to distribute load and a perfect example of how simple geometric shapes can play a big role in structural design. Then we moved on to the art of arches, diving into the funicular shape, vertical reactions, horizontal reactions, and thrust. Remember the three-hinged arch? It's a classic example of how an arch can distribute load, with the added benefit of flexibility. Next, we focused on rigid frames, where vertical and horizontal members work together as a single structural unit. We used the analogy of a gable frame one-story building to illustrate this concept, emphasizing the contrast to a post and beam system. Space frames, those three-dimensional trusses, were our next stop. We looked at how these structures, especially triangulated space frames, can span large areas without interior supports, creating versatile and open spaces. Our journey ended with inflatable structures. We talked about double-skin inflatable systems, a modern and dynamic approach to structural design that offers flexibility and portability. Now, why is all this important? As emerging architects, understanding non-standard structural systems such as these is crucial. By gaining a better understanding of structural systems like space frames, arches, and inflatable structures, it'll make you a better architect while also making it easier for you to pass your architecture exams. If you found this video useful or enjoyable, please like it and subscribe to our channel. Until next time, keep learning, keep exploring.